Hello dear students. This video is created for education purpose only. Myself Meena Labde, Assistant Professor in Mathematics, Maharaja Jivajirao Shinde Mahavidyalaya, Srigonda District, Ahmednagar. Dear students, we have started our SYBSc Mathematics paper 2nd, Numerical Methods and its applications. So we have completed our unit number 1 and unit number 2. Now we have started our unit number 3, Numerical Differentiation and Integration. So this is our lecture number 3. In the previous lecture we have seen general quadrature formula for equidistant ordinates. Now in this lecture we are going to derive integration formulae with the help of general quadrature formula. So very first integration rule is trapezoidal rule. So we know that the general quadrature formula for equidistant ordinate is integration a to b y dx, and for that a you may call this as x naught initial argument, and the final argument is x naught plus nh, so that is nothing but your b. So remember this is your x naught and that is nothing but your a, and x naught plus nh is nothing but your b, and the integration is same y of x dx. So y is a function of x, and we have derived this formula in the last lecture. So integration x naught to x naught plus nh y dx is h outside. What is this h? H is interval of differencing, and in bracket n y naught plus n square upon 2 delta y naught plus n cube upon 3 minus n square upon 2 delta square y naught upon 2 factorial plus n raised to 4 upon 4 minus n cube plus n square delta cube y naught upon 3 factorial plus etc. Now for trapezoidal rule we are putting n is equal to 1 in this equation. So if you put n is equal to 1, so you are in interval, so you are putting n equal to 1 here. So here lower limit is x naught and upper limit is x naught plus h only. So your interval of integration will be from what? X naught to x naught plus h. Also one more thing is that as there are only two functional value, so for x naught, so value of f at x naught, and you may call this as y naught. So f at quite difficult job to write this equation using this mouse. So f of x naught is nothing but your y naught, and the next argument is x naught plus h. So that is your, this is y1, so value of f at x naught plus h. So as there are only two functional value y0 and y1, so only two values are known, so there are no differences higher than first, so neglecting second and higher differences, because you in our hand we have only two functional values y0 and y1, and therefore you can say that second difference is 0, second and higher differences. Therefore we are neglecting second and higher differences from where? From this equation of general quadrature formula. So what happened? So integration x naught to x naught plus h y dx. So we are neglecting differences higher than 2, so this term will not be there. So we just want this term and this term. So in the next equation we have written y naught h y naught plus 1 upon 2 delta y naught. So we know that the definition of delta y naught, what is that? So this is delta y naught is forward difference. So forward difference is succeeding minus preceding. So delta y naught, y naught चा पुढचा कुठला आहे y1, so y1 minus y naught. So we have just right here, instead of delta y naught is y1 minus y naught, and if you simplify this, so y1 by 2 as it is, and this plus 1 and it is minus 1 by 2 is plus 1 by 2. So you will get that integration is h outside y naught plus y1 divided by 2, and the interval of integration is from x naught to x naught plus h. So therefore you will get integration x naught to x naught plus h y dx is h outside, so y naught respective value of f at the lower limit, that is y0, and value of f at the upper limit is y1. So y0 plus y1 divided by 2. Now similarly, so next interval will be x0 plus h2, x0 plus twice h, y dx. So again it is h. So from this you can write this h, y1 plus y2 upon 2, and again if you take the integration from x0 plus twice h to x0 plus thrice h, so what will be that? H outside, value of function. Now the this is the which number of argument? So x0 is first, then x0 plus h is second, and x0 plus twice h is third. So value of f at this x0 plus twice h is your y2, and this is value of f at x0 plus thrice h is y3. So h outside, y2 plus y3 divided by 2. In fact, we'll get general formula. So x0 plus n minus 1 times h to x0 plus nh is h outside. So this is value of f at this argument, and that is nothing but your yn minus 1, and value of f at the last argument is yn. So h outside, yn minus 1 plus yn upon 2. So this we have written from similarly, and this is the general formula. So adding all these equations, so you will get very first integration. First we are going to write our LHS x0 to x0 plus h. So which we are going to add? This equation, this equation, and this equation. So LHS is very first x0 plus h y dx, then x0 plus h2, x0 plus twice h y dx, plus x0 plus twice h to x0 plus thrice h y dx, plus etc. And this last integration. So this I have written this, and you know that formula, which is that integration a to b f plus integration, what is that? This upper limit here becomes lower limit. So b to c f, this is the property of integration, and that gives you integration from this bb will get cancelled, and this is integration a to c f. So remember this property, and we are going to apply this property. So for these two integration, that x0 plus h, so integration will be from x0 to x0 plus twice h. Then again here x0 plus twice h is same, so twice h, lower limit is same, and the upper limit will be this one, x0 plus nh. So I am going to rub this. Let us remember this. We have used that property, integration a to b f plus integration b to c f is integration a to c f. So and finally you will get it is integration x0 to x0 plus nh y dx, and collect the RHS term. So for very first integration, your term h is common in all these terms, so you can take outside of that bracket, and in bracket very first term is y0 plus y1 divided by 2, for second y1 plus y2 divided by 2, for third y2 plus y3 divided by 2, etc. And for this term yn minus 1 plus yn divided by 2. So y0 is so simplify this, y0 by 2 and yn by 2 you can take outside. So 1 upon 2 y0 plus y1. Now this y1 by 2 and this y1 by 2 becomes y1. Again y2 by 2 and this y2 by 2 becomes y2, etc. yn minus 1 by 2, and here will be yn minus 1 by 2, and that becomes yn minus 1. So remember this. So integration x0 to x0 plus nh y dx is h outside 1 by 2 y0 plus yn plus y1 plus y2 plus etc. yn minus 1. So how to remember that formula? So whatever that integration is, take h outside. What is that h? H is the interval of differencing. Then 1 upon 2, then value of given function, very first value, that value of function at initial argument, value of function at final argument. So first and last term y0, y0 and yn, and divided by 2 is there, and plus add remaining term except first and last term. So this is known as a trapezoidal rule. So remember this trapezoidal rule. It is easy to remember. So just edge outside 1 upon 2 first and last term, and plus the all terms between first and last. So let us see examples based on trapezoidal rule. So very first example, you have let the integration from 0 to pi x sine x by trapezoidal rule, and we have given that by dividing the interval 0 to pi into 5 sub-equal intervals. So here we have to divide this interval into 5 sub-equal intervals. So we may call this integration as I is equal to integration 0 to pi x sine x dx. So one more thing, we have to divide this interval into 5 sub-intervals. So n is nothing but here number of intervals. So here n equal to 5, and therefore length of each sub-interval, how to compute this? Length of sub-interval h equal to b minus a divided by n. So b is upper limit, a is lower limit, and n is number of intervals. So 0 minus, sorry, I have here b is nothing but upper limit, so b is pi, and a is your 0. So sorry, a is 0 here, so pi minus 0 upon 5, and that is nothing but pi by 5, and therefore arguments for x are, so initial argument is very first 0, and then we have to divide this sub-interval. Let me erase this. Which interval we have divided? Suppose here is your 0 and here is your pi, and we are dividing this into how many? This is first interval, this is second, this is third, fourth, and last will be fifth. So 0 to very first is length of interval is pi by 5. So second is pi by 5, then second interval pi by 5 to 2 pi by 5, 3 pi by 5, 4 pi by 5, 2 pi by 5 is repeated here. So 0 to pi by 5, then 2 pi by 5, 3 pi by 5, 4 pi by 5, and 5 pi by 5, that is nothing but your pi. So these are the arguments for x, and now we are going to write the corresponding values of the function y equal to x sine x. So in very first row we have written here the argument 0, pi by 5, 2 pi by 5, 3 pi by 5, 4 pi by 5, and pi, and x sine x. So x, and at the value of x compute sine x and make this calculation. This is nothing but your y. So here is 0, then x pi by 5 into sine x is whatever there, so it is 0.3693. So remember here you have to compute sine x in radian mode. So remember, don't make the calculation of sine x in degree mode, so that will change here the values of the function y. So as these values are given in radian, so you have to set your mode of calculator in radian mode. So change the mode of your calculator and make this calculation in radian mode, and check whether these values of function are correct or not. So these are the values, so you may check, and now you can rename this as very first is y0, then obviously second is y1, third is y2, then y3, then second last is y4, and the last is y5. So this we are going to put in the formula of trapezoidal rule. So therefore I have written here y0 is 0, y1 is 0.3693, y2 is 1.1951, y3 is 1.7927, y4 is 1.4773, and the last is y5 is 0. So write all these yi's from the given table. Y is nothing but your value of function at x. So therefore by trapezoidal rule, write trapezoidal rule general formula x naught to x naught to xn, y dx is h 1 by 2 y naught plus y1, yn last initial and last argument, and then addition of all values of the function in between. So this is the formula. Now we have only uh, values up to y suffix 5. So this is 5 by 2. H is interval of differencing. So this is pi by 5. So pi by 5 into 1 by 2. Initial argument is 0. Y naught is 0 here. Yn is again 0. Now y1, y2, y3 up to y4, because last term is included here, and we have add all these terms and simplify. You will get I is equal to 3.0375, and this is the answer. Integration 0 to pi x sin x dx is 3.0375. So remember this, how to integrate given equation by trapezoidal rule. So remember this trapezoidal rule. Next example, find an approximation to the integral. The integral is 0 to 4 square root of x dx by trapezoidal rule from the given data. So sometimes this data is given, and if data is not given, so we have to prepare as we have done in the previous example. One more thing is asked. Also find error in the solution by evaluating actual integral. So this integral we can evaluate actually, and will calculate the error in these two solutions. So let whatever that function is, y equal to f of x square root of x. So here observe the interval of differencing. So 0 to 1, 0, 1, 2, 3, 4. So interval of differencing is h equal to 1. Now these are initial arguments. So y naught is 0. Then this is y1 is 1. This y2 is 1.41, this is y3 is 1.73, and y4 is 2. So we have written this. Now write down the trapezoidal formula. So therefore by trapezoidal rule we have integration x naught to x, y dx is h 1 by 2 y naught plus yn. Y naught is initial value of the function, yn is last value of the function, and plus addition of in between terms. So it is 0 to 4, whatever y is there, root x dx, 1 is there, 1 by 2, y naught is 0, and yn is nothing but up to how many? We have just written up to 4. So sorry, it's not up to this. We need y1 plus y2 plus y3. So this is your y1, this is your y2, and this is your y3. So simplify this, and you will get answer is 5.14. Now this answer is by using trapezoidal rule. Now we will find exact value of the integration by actual calculation. So we can compute the integration of this square root of x. Square root of x is nothing but x raised to 1 by 2, and integration is x raised to 1 by 2 plus 1, that is nothing but x raised to 3 by 2 upon 3 by 2 within the limit x equal to 0 to x equal to 4. So simplify this, you will get answer is 5.33, and previously what was the answer? 5.14 by numerical integration, and this is the actual computation. So error is nothing but exact value. Formula for error is exact value minus approximate value. So this is your exact value. So 5.33 minus approximate value, which we have computed by using trapezoidal rule, and that is nothing but 5.14, and you will get that is 0.19. So this is the error we got in the computation of numerical integration. So these exercises I have given for you. You have to solve these integrations by using trapezoidal rule. So very first 0 to 10 1 upon x dx, and here we have asked to divide given interval into 10 equal parts. So in that case, find out how many parts? 8 equal parts. So this is your n, and formula for h is, we have already done in very first example. So it is upper limit minus lower limit divided by n. So b is 10, a is 0, and n is 8. So 10 by 8, whatever, compute this and find the values of y at respective values of x. So write here arguments and write here value of function is nothing but your y is equal to 1 upon x. Whatever x is there, compute this term and you will get value at y is equal to x. So another second example is estimate the area bounded by the curve x-axis, the extreme and the extreme ordinate. So curve is given by the point. So this data is given. So this is nothing but 0, 24. So data is given in the x and y order pair. So very first ordinate is for x and second ordinate is for y. So whatever these initial arguments are given, these are the values of x. So 0, then 0 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5 and 4. So this is the first row of your table, and then at the second row you will get 23, 19, 14, 11, 12.5, 16, 19, 20 and 20. So whatever that table, perform this table, apply the trapezoidal rule and simplify this, you will get answer is 66.5. So we have not given the unit, so your answer will be area of the curve is 66.5 square per unit. So this is all about trapezoidal rule. Now in next lecture we are going to see another rule for numerical integration, and that is nothing but Simpson's one-third rule. So let us stop here.